and all. Subject name is compiler design. In this subject, we have discussed some of the problems which are related to different types of parsers. That is whether the grammar is LL1 or not, and what are the LR parser procedures and SELR and LLR parsers. So the problems which are related to parser, which we are going to be brief on. So these are the computations which we have discussed previously, whether this grammar is LR grammar or not, based on the past table implementation and flow graph. All the things we can discuss with this as simple examples only. So SLR grammar and SLR and CLR, SALR. So SLR grammar, which derives the data flow diagram with this one with the help of these productions. And in this one, the closure of items can be easily found with the help of the states, that is I0, I1, I2, I3. And what is the differences? We are going to find this with this an example also. See, all the computations I0, I1 to be computed with the help of the closure of items. So here first initially we are going to add an augment production. That is what is here that is given, and then we are going to after this list out the remaining productions with the dot symbol at the beginning of right hand side of each production. So that's why we are going to list this one and they name it as one state, that is I0 state. Now in this state I0, what is the closure of items can be found. So what is the closure of items? Here we can find I0 comma E and I0 comma capital E, I0 comma capital T, that is one closure of item, and F and D, I0 comma capital F and I0 comma small d, so ID, identify. Now we are going to perform E for capital E. What are the productions related to these two? So S derives dot E and E derives dot E plus T. Now if you apply, then we will get I0. If you apply the closure of I0 comma E, so each dot period one symbol head. So E derives, S derives E dot. Now E derives here dot E plus T. Now we are going to perform capital E. So one period, one symbol head means here E dot. Of that plus and then T. E dot plus T. So this is the state which is called as I1. So what is the state contains is I1. Now I1 is to be kept that one, and the next we have performed this one. Next you can perform T, I0 comma T. So here capital E derives, what is this one? Dot T, and T derives dot T star F. Now this is the state in this one. These are the symbols available. This is the process available. Now we are going to perform I0 with capital T. That is closure of I0. Closure of I0 with symbol T. So what we get? E derives T dot and T derives capital T dot star F. So these two derivations are to be included in this state I2. So I2 is not completed. Still further processing is there. So we are going to list out both I0 comma E and I0 comma T. We processed and we generated a new states I1 comma I2. So like that you can generate a new state for another one I0 comma with capital F. So what F contains here in this one? T derives F. So T derives F dot F. Now that is raised to T derives F dot. So only one production is there. So that is to be noted down with a new state I3. Then what is identifier here? List right hand side, only one production, F derives dot ID. So that is to be computed with F derives dot ID with I0 comma small ID, small I, small d. And then it derives a new production, that is F derives ID dot. ID dot. So that is the production which is available, that is as I4. So we reached one closure of the, after finding the closure of items, we will get the some of the new states that is generated, that is called as I1, I2, I3 and I4. So these are the states which we reached after finding the closures. Now from this we observe that any states still processed or not. So this is I1, this is I2, and this is I3, and this is I4. Now from this we are going to find any processing of closures for the remaining states. So here the period is not completed, still it is going on. So that's why I2, this is I1. So capital I1 with here in this there are two productions. One is S dash derives E dot, that is reached, and another one is capital E derives E dot plus T. Now this is processed, but this is not processed. That means a period end of the symbol is not reached. So that's why we have to process with the symbol with the corresponding state. What is the state? Here the state is I1. So I1 with closure plus closure of this one. So plus after perform will get the new state, that is E derives E plus dot T. Now what is the productions which are available for T, that is to be included. So in the given list what is to be included, that is T derives dot T star F and T derives dot F. So this T derives dot F and F also we have to include. So F derives dot ID. So F derives dot. So all the productions which are performed with the period, that is to be included. So what T derives, what F here after T completed, what F completed. No ID there is no. So that's why you can stop this one and name it as one state, that is called as I5. From I5 once again we can perform this. Similarly for I2 also these two productions are there. I2 which contains E derives T dot, capital E derives T dot. This is the reached end of this one. So this one we cannot do further closures. Whereas the second production D derives T dot star F. So it is not reached end. So we can perform once again. So this one is to be covered. So what is to become I2 comma star. I2 comma star will get what? T derives T star dot F. T derives T star dot F. Now we reached this, now we are not reached. But here we have to include the productions related to F also. Why? Because it is a after dot period, capital F is non-product. So non-terminal which are related to capital F is here. What is F? In the given list, F derives ID. So that is to be included. F derives dot ID. So these two comes under as a new state, that is I6. A new state that is formed with I6. So this is the list I6 which contains these two. And then we have computed I3, no need to compute. Why? Because it contains T derives F dot. After dot period, there is no variables or any other doesn't exist. So that's why we can stop the I3 state. Whereas I4 also we can stop the processing of this closure of items. Why? Because here also it reached to the end. So F derives ID dot. So only we have to process the states, that is I5 and I6, because it is not reached. So I5 once again we can simulate into that closure of T. So closure of that is I5 comma capital T. So here dot after dot T capital T. So that's why capital T we can perform the closure of I5 comma T. Then we reached a new state, that is I7. Follow the same procedure. Where dot appear and check whether that terminals are available or not. If it is available non-terminal, then go through the given list and add, repeat the procedure. And from I7 is to be reached. Again, we have to find capital T we have computed, then capital F and capital ID also. Then after capital F, it derives, if we perform I5 comma capital F. Then already the production which contains T derives dot F. Now if you perform I5 closure, then it receives the production as T derives F dot. Now what it is already the state S3, I3 contains this production only. So instead of writing a new state, we have to write what? A transition label which is marked as star. That is F, which is marked as F. So IF based on F state I5 with closure F operation will getting a state reached to the state I3. Now last one that is also available F derives dot ID. So here also we can perform F derives dot ID after implementing this closure of I5 comma ID. What we are getting F derives ID dot. So F derives ID dot already available in I4 state. So that's why you make a transition I4. Verify whether the previous states which contain the same list or not. If not, we can make it as a separate state. If already existing available, then simply we are going to make a transition of this graph from this state and then to this state, to this new state, and make this as a label ID. Make this label as ID, and we can. So like this, the I6, the I5 states are completed. Now you can from I5 you can generate. We have generated a new state I7, and from I7 verify whether any new state is to be generated. So here from I7 there is no new state is to be generated. Why? Because it reached. You see here I7 which contains two things. One is E derives E plus T dot. So here it is reached end, so no need to compute. And T derives T dot star F. But here we have to perform what? It is not reached. So that's why I7 comma star. What is I7 comma star? T derives T star dot F. T star dot F. So here F doesn't contain F is a non-terminal which contains the productions. So here what is ID? So that is to be included. F derives dot ID. So identifier it is no need to expand. So that's why these two productions are to be available in the state I6. So simply we make the transition as a star operation and then we compute it is to the X. So it is same as I6. Now that's why you can extend the further with I6. So I7 is stopped at this place. So I6, what is the I6 contains? Here we have stopped the I7 process. Then I6 which contains the list of two derivation, that is one is T derives T star dot F and another one is F derives dot ID. Now here we are going to compute closure of I6 comma F. So I6 comma F which gives the result T derives T star F dot. So T derives T star F dot. So from this there is no other symbols are available. So we can stop this one and make it is a new state. So that's why it is a new state I8. Why? Because on F, transition F, we are going to generate a new state I8. And then one more production it is there. So from this we reach to the state I8. From this you have to apply once again I6 comma ID, small ID. So what is the resultant? Here we will get F derives ID dot. So here also no need to compute once again closures. Why? Because it reached the end. So this is the state is already available or not? Yes, it is already available. I4. It is ILL. So simply make a transition, just an arrow which gives the resultant. So this is the end of that is the closing of all the closure of all the states. Why? Because I7 is stopped, I8 is also stopped. There is no further symbols are available to compute the next related derivation. So that's why we make the states that is I0, I1, I2, so on up to I8. So the generation is IT. So we have to write that list of states as a row wise. I0, I1, I2, I3, I4, I5, I6, I7, I8. And then we have to compute the two sections, that is action part and go to part. Previously also we have computed just I not what is the closures with corresponding labels. That is, for example, this is the state I naught, and in this example, capital E is capital T, capital F, ID. Now, what is the state it is reaching? That is I naught with capital E, it is reaching to I1. So that's why capital E with 1, state I1. So these non-terminals ETF is to be written as column wise, and ID plus star dollar symbol is to be written as with the action part. So two parts in the column wise. Again in the go to we are having a non-terminals. So each non-terminal with the corresponding state. Suppose you take I naught. What is it is stating? E, capital T, capital EF. So which state it is reaching? With capital E it is reaching I1. Capital T it is reaching to I2. Capital F it is reaching to I3. So that is to be written with a notation I2, I3. That is 2 for capital E, what is the state? 1. For capital T, what is the state? I2, 2. Capital F, similarly for ID. What is ID? ID is to be description with the S here for I4, but we are going to write is in the shift manner as the action part. So S4. Like this for each state I1, I2, I3 we have to write. But in case of the productions which contains the end, suppose I3. In this example, if you take I3, so this I3 which is reached to the end. That means from that there is no transition takes place in this one. Similarly for I4 also there is no transition takes place. This one I3, I4, these two productions. Similarly I7 and I2, I7 and I8. So what is I3? So here I3 which contains T derives F dot. I3 is T derives F dot. Now this is to be T derives F dot. So this is the reduction parts where you are going to write the where do you have to write this the rules, derivation rules with R1, R2, R3, R4. You have to write the derivation rules with this one. That's one. Suppose this is. I have to write list out this one as separately. R0 is 1, R1 is first rule, second, third, fourth, fifth. This one we have to write as a, so I4 in case of this is I3. So I3 which contains the production T derives F dot. So this T derives F dot is available in which rule? Is it in derivation rule of R0, R1, R2, R3, R4? So here this is available as R4. So that rule is to be written with the R4 with the corresponding items, that is plus, star and dollar. You have to include this R4. And similarly for I3 is completed. I4 also F derives ID. See, F derives ID is the last one. So I5. So the R5. So this R5 is to be written across the rows of all the action parts of this one. And I7. I7 is the one which contains the I7. It is to be considered here I7. E derives I7 which contains E derives E plus T. So E derives E plus T, that is to be written as R1 plus del. And we have to write the shift part also. Why? Because it also contains a star operation with a new state it is generated. So at this case, suppose if the reduction is ending with only one production, that is we have to write that reduction or R1 or R2 with the all the columns of all the rows of that one. Whereas if there is a mixed, that means which contains R and star also, then in this case we have to write the R1 in all the cases, and where the star is extended to further state. So that is to be considered as S6. So R1 is to be written for the remaining cases. Similarly, for the last one, I8. So I8 is the production which contains T derives T star F. Now this is to be available in R3. So this R3 is to be written with the plus star, and so we have to compute the closures of the items like this one. I5, suppose if the state I5, then we have to compute with the corresponding I5 with capital F, I5 with capital D, ID, and then we have to repeat the procedure if the any non-terminals appears once again. So like this graph wise also we can implement. So first initially we have started with the grammar augment production, inserting a dollar symbol that is to be included one part, and remaining all which is to be given in the that is grammar, that is listing out the productions. First we have to take the initial state I0 and list out all the production with the augmented grammar, and they find the closure of each items one by one with the help of the non-terminals and terminals that are to be reached to the corresponding states. And we found that some of them are reached and some of them that is we found the reached states I7, I3, I4, I7, I8. Remaining is to be included as part of this one. After this we have to write some of the cases if where first of the computation exists, then we have to write the first of E. So previously we have computed how the first of E based on the rules we can compute the first. So first and follow. What is the follow of this one? First of this one, S derives capital E and E derives capital E plus T. E derives T derives T star F, T derives F derives I. So in this computation, what is the first of E is nothing but the two derives. So E derives E plus T and E derives T. So we have to write the what is the first of E here. First of E means first of E plus T, then first of T. So that is to be written with this one, union of both the cases. So what is first of T? First of T already it is there. It is the first of T star F. Once again first of F. Why? Because T contains T star F and another one is T derives F. So based on the union of these two we'll get. Once again, what is first of F? We'll get first of F is ID. Why? Because it is the only production which contains F derives ID. So first of F is ID, and from this first of T will get, that is with T star F we'll get first of T is ID and first of E is also ID, and follow of E. These are the three things, that is ETF. So for this grammar, what are the first to become computed is one is first of E, first of T, and then first of F, ETF. So that is to be computed with this one. So ETF we are getting this one as ID, and based on the rules are defined with the follow computation, we have to make sure that this one is also computed. What is follow of E? So here E, follow of E is plus T. So that's why first of plus T, and that this is a starting symbol of the given grammar. Yes, so that's why you have to include what? Dollar also. So dollar is available. What is first of plus T? Here first of plus T is where T is not included with epsilon. So you have to verify whether T contains any epsilon. So if it belongs or not belongs to, does not belongs to epsilon. So in this case it does not belongs to epsilon. So we have to compute first of plus T is plus. So that's why we will get plus dollar. Similarly, follow of T. What is follow of T? We have to write the production. So that is this follow of T. So what is follow of T is star F. First of star F and union. The here non-terminal is available. So that's why first of union, first of F. So what is the first of F? So that is already we have calculated with this one. So ID. First of F, ID. So place first of star F is star and F is E. First of E. That is not F here, first of E. So that's why plus dollar star plus dollar. And similarly follow of F is we have computed with follow of F. Where follow of F ID. What production it contains? F is only one production, that is F ID, and that is F follow of E. Follow of F. So where the F is available, so in this one T derives T star F and T derives F. So T derives F. So that's why you are getting same thing. For this one also star plus dollar. So we have to compute and make sure that this is to be with this available in the given parse table, and then generate the remaining entities which are to be computed. So here where the rules are to be appear, finding the closures, main important one is finding the closures, and we can come across this as a computation of the flow graph and parse table. So this is the given problem, and we have computed closures and parses. And thank you all of you. Thank you. We'll come up with the next session with a new topic, with one more example of it and a different topic. Okay, thank you all of you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.